Good morning, everybody. Oh, it is so nice to see you all here. We've got a two-part session here. This is part one of two. This is a Blazor deep dive, and so I'm going to start kind of assuming you know nothing. And by the end of the second hour, hopefully you'll know everything. Introductions. My name is Lhotka. I work for a company called Zebia. We do software consulting and development and cloud and GitHub and AI and all of the, cool stuff, basically. And also, I am a track chair for VS Live, and so I'm one of the people that helps organize the content for the show. I've been doing this for a long time, and in the Microsoft space, I've been doing this since Visual Basic 1. And so you think about, at least I think about Visual Basic, and then that gave way to .NET, but in a sense it gave way to Windows Forms and Web Forms. How many people use Windows Forms? Web Forms? Yeah, quite a few. And then WPF. Yep. And ASP.NET, yep. And of course, then we get into the modern .NET, the .NET ASP.NET Core, Razor Pages. How many people did Silverlight? All right, a couple, okay. The reason I'm walking through all of that is I too have used all of those over the years at different capacities and in different situations. Every time that Microsoft comes out with a new UI framework, it seems like they have done a pretty good job of looking through the past and saying what worked and what didn't work, and how do we improve the overall experience. And to that end, Blazor, being the newest of the UI frameworks, and that's kind of funny to say because Blazor is now a number of years old, but it's the newest of the UI frameworks. And in my opinion, it is by far the best that has been created since 1991. So this is why I'm here talking about it, because I think it's a very compelling technology in that regard. All right, so with all of that said, like I told you, I'm going to start from the beginning. So literally, how many of you have not used Blazor? So yeah, reasonable numbers. That's excellent. So Blazor, like I said, is a UI framework that is designed to allow us to create very rich interactive experiences for our users that run in a browser or on a mobile device, but I'll get to that in the second half. But generally speaking, the way to think of it is it's designed to run in a browser, give the user this rich, highly interactive experience comparable to what you could do with Windows Forms or WPF. Right? So the same level of interactivity, except it can run anywhere that a modern browser can run. So any modern device, right? Mac, Windows, Linux, iOS, Android, whatever, because all of them support modern browsers. And by modern browsers, of course, what I'm talking about is the Chromium family, so that would include Chrome and Microsoft Edge and a whole bunch of other browsers, the Safari browsers, Firefox, etc. So probably most of us are not using anything else, hopefully, at this point in the world, right? From a history perspective, and if you'll indulge me, a while ago, I was actually in Redmond giving a VS Live, but at the Microsoft headquarters, and I gave this talk there, and a couple of the people from the Blazor team were in the back of the room when I told this story, and they were just cracking up because I don't work for Microsoft, right? I work for a Microsoft partner, but my perspective is an outsider's perspective, and of course, they lived the real story, but I'm going to tell you Rocky's history of Blazor in summary. And I think this is interesting to understand how these technologies emerge, but also for the couple people that use Silverlight and may still have some sour memories of Microsoft killing Silverlight, a lot of folks in that situation look at Blazor and they're like, wow, well, this feels a lot like Silverlight. Maybe it's risky, but it's not. because it's fundamentally different in so many ways, even though it accomplishes the same goal. And so if we go back in time, quite a few years now, well, actually in my case, if we go back to roughly the year 1999, 2000, those that were in the industry at the time might remember it was a very heady time, right? There was well, in fact, VS Live at that time, the demographic was completely different because we had high school dropouts, college dropouts, regular developer folks that had, were kind of the normal VS Live audience. And then on top of that, we had people with suits walking around looking for developers because they had this cool idea about how to change oil on the internet. Or, I mean, it was, this was the .com like bubble, and everybody thought they were going to make their gold rush fortune by creating a website, right? And so these conferences were fun. And in the speaker rooms, because there's always a speaker room, right, at these shows, the speakers frequently sit and then have conversations about where we think the world is going. Right now, all those conversations tend to be centered around AI, of course. But at the time, they were centered around the role of the browser. Like, should the browser continue to be a very colorful terminal, similar to a mainframe terminal, a 3270 or a VT100 type terminal, because that's how a lot of people thought the browser worked at the time. And then the web servers were like mainframes, right? And there were people championing that because it solves a bunch of problems. There were other people that looked at the browser because at that point, right, VB script and JavaScript were really quite new and were just catching on, and people were thinking, oh, wow, we could ignore Windows, we could ignore the Mac. Basically, we could ignore the underlying operating system, and the browser could be the target for all application development. It could be the new runtime. Well, the .com collapse happened, and we just kept doing browser as a terminal for the most part until the iPad showed up. So, we moved forward basically a decade, 2008, 2010. The iPad shows up and scares everybody because we had this blissful decade where, well, of course you're writing for Windows. Every company runs Windows. And then all of a sudden, overnight, we were living in a post-PC era, right? And none of us have PCs anymore, of course, now, because we all run everything on iPads. And I look around the room and I only see iPads. Oh, wait, maybe not. But I mean, you can't underestimate. There was that 2 or 3 years there where everybody was just scared that if you didn't support the iPad, you were completely done for, right? And companies, I've been in consulting for a long time. This was a moneymaker. Oh my God. Because you've got all these executives, CIOs, CFOs, CTOs, whatever, that ran out, bought an iPad, and then found out that none of our software, none of our business software could work on it. And they said, well, you need to make it work on my iPad. And we're like, you realize that's a complete rewrite. That's millions, billions, trillions of dollars. And they're like, I don't care. I want it to work on my iPad. This thing costed me $300. And so, like I said, as a consultant, we made a lot of money doing really stupid stuff. I mean, if you think about it, right? Perfectly good software had to be rewritten so that it would run on a stupid iPad that now nobody uses, right? But that's okay. That's why we're in consulting, because when people make dumb decisions, we make money. Moving on, what really came out of that is that it was too expensive to write software for Windows, for the Mac, for iOS, and then for Android. It's just too darn expensive. Even today, with Maui or Flutter or some of the modern mobile tools, it's still really too expensive. And so almost nobody actually does that. We just all build web apps. But our users want a good experience. And so this is ultimately what drove the browser to become the modern platform for app dev, right? It's the target platform. Does anybody here write, I mean, yes, you maintain, but do you write new Windows apps? Yeah, a couple, right? How about new Mac apps or new Linux apps, or, right? I mean, it's very rare, is my point. because it's just too darn expensive for most of us to be doing that. So how do we end up with rich interactive user experiences? Well, we write JavaScript frameworks. And so then we go through this period of time where you could pick a noun, put JS at the end of it, and that was your new framework, right? And that was crazy time too. You know, today, basically, it's either React or Angular, right? And yeah, I realize I'm pissing some, you know, oh, there's Vue and there, you know, there's a whole bunch of different ones still, but you know, the big dogs are clearly Angular and React. And those are fine as long as you're willing to program in JavaScript or TypeScript. And JavaScript, probably not so great, but TypeScript is actually pretty good, so I'm not saying these are horrible. But if I'm a .NET developer, which I am, then I'm like, well, why can't I use .NET, right? Or if I'm a Rust developer or a Go developer or a Java developer, why do I have to go learn this other programming language? And so Mozilla, the Mozilla Foundation, the people that create Firefox, did this thing, geez, I don't even know, 7, 8 years ago now, called WASM. It was a prototype concept of an assembly language that could run in the browser. So instead of JavaScript, you would run an assembly language. Well, nobody wants to write assembly language, so you compile C or C++ into this WASM code that could run in the browser via assembly language. And that prototype worked well enough that it caught some traction. And if we fast forward now, you know, several years, WebAssembly is now in all modern browsers as a first-class construct. And so WebAssembly is in fact an assembly language that runs in the browser natively. So where it used to be only JavaScript, it was a monoculture. Now it's JavaScript or WebAssembly, both of which still have HTML and CSS on top, right? So, and I'm going through all of this because Blazor kind of comes out of this. So this WebAssembly thing is happening. There's an open source version of .NET out there called Mono. And the Mono team, which Microsoft acquired, but at the time, the Mono team looked at WebAssembly and went, oh wow, if there's an assembly language in the browser, we could make Mono run in the browser. So they did. So all of a sudden, you've got .NET running in the browser. Like, okay, that's pretty cool. Then you've got Steve Sanderson at Microsoft out of the ASP.NET team, and he looks at that and goes, wow, if .NET's running in the browser, I could make the ASP MVC Razor page rendering run in the browser. So he created a version of Razor pages, you know, CSHTML files called .razor files that literally can run in the browser on top of .NET running in the browser, right? So this is the first incarnation of Blazor. And it was very cool and caught a bunch of, like, my imagination. A lot of people I know were like, oh, this is really cool, right? The Microsoft executive team looked at this and went, holy crap. Like only 2 or 3 years ago, we killed Silverlight. Everybody hates us. This looks exactly like Silverlight. We can't do this. And so they went back to Steve and those guys and said, you can't do this. But of course, you know, these things get a momentum of their own, right? So the ASP.NET team said, okay, how about if Blazor runs on the server and we use a technology called SignalR, which provides a real-time connection between 2 points on the internet through firewalls and everything else, okay? And so what that would allow us to do is our Blazor code is running on the server. We put some JavaScript in the browser, so as the user clicks or moves the mouse or does anything in the browser, we are sending events. They're very small, right? But just like, ooh, the mouse clicked. The user hit a key, you know, whatever. We're just sending these little events down to the server. The server processes them and then sends events back up saying, oh, this value changed, that value changed, update the UI. So you end up with this immediacy, right? That feels like all the code's running in the client, but it's actually all running on the server, right? And then they did that, and the Microsoft executives were like, yes, you can do that because that's fine, right? And they kept doing the WebAssembly thing because that was cool, but it was kind of like on the QT, right? So when Blazor was first released, Blazor was a server-side technology with this experimental WebAssembly stuff. Now roll forward, that's Blazor 1, 2, 3, all the way through 7. Basically kind of followed that philosophy. Blazor 8, so 2 years ago roughly, merged the two and said, all right, now when you create a Blazor app, you get to choose, do you want server-side only? Do you want client-side only in WebAssembly? Or do you want this really clever graduation scheme where it starts on the server and graduates to the client? And I'll get into the reasons why this is beneficial here in just a minute. But that's where we are today with Blazor 10. Right, only that's matured, it's had a couple of years to mature. So the first thing, of course, that I would do with any web technology is say, all right, the big dog is Angular. How does Blazor compare to Angular? Well, it compares, I think, today quite well in that in both cases, you're basically using HTML, CSS to do your graphical UI design. So you've got all of that consistency there. Instead of TypeScript or JavaScript, you get to use C#. Yes, that to me is a big win. Yes, it's C#, but it's actually the entire tool chain, right? I get to use Visual Studio or VS Code. I get to use all of the .NET NuGet packages. The world that I live in now works, right? Rather than I get to use the world I live in to write server-side stuff, and then there's this whole other world with NPM and all this other stuff that I have to know to do Angular, right? So I have to literally learn two entire ecosystems and keep up with it as they both change, right? So this, to me, is a huge win for Blazor. And I should say, too, really React, Angular, even though they are not very similar, they fill the same role in this conversation. And before I move on, I frequently get this question. People are like, man, we've really invested in React, and we've got a lot of software written in React. Should we go to Blazor? And my answer generally is no, right? I mean, why would you do that, right? You've already got a whole bunch of your staff, your people, that are trained and competent in React or Angular. They understand that ecosystem. I'm not confident that Blazor offers any benefit if you've already got the skill set. You see what I'm saying? On the other hand, if you're coming at this whole thing and you're like, we've been sticking with Windows Forms, Web Forms, MVC, WPF, whatever. We haven't gone down the Angular or React road, at least not very far. And most of our people are .NET developers. Now Blazor becomes really compelling because you don't have to build up this whole new skill set in this whole other ecosystem. You can just keep doing the technology that you already understand. Right? This is the way I tend to frame it. It's not really a technology decision anymore because they both can do the same thing. It becomes a business decision about training, staffing, that sort of thing. Here, WPF is also a stand-in for Windows Forms, all right? So Windows Forms, WPF, if you've got, and a lot of us do, a lot of you raised your hands, right? You've got legacy apps, maybe your primary legacy apps, right, are running in these technologies. And you're like, man, it really would be nice to not be stuck on Windows. It would be really nice not to be stuck on aging technologies. Yes, Microsoft continues to keep Windows Forms and WPF maintained and working, but they're not investing in them, like as in new features, right? I mean, those technologies, everybody wants to call technologies dead. They're like, ooh, that's a dead technology. And I would never say that about either of those because they're not. They're actively maintained, right? What they are, in my opinion, is done. They're baked, right? They're complete, right? They're in maintenance mode, and they probably will be for the next 20 or 30 years. And so on one hand, that's really good because once you've learned WPF, you're not going to have to learn anything new for the next 20 years, which to me sounds really boring. But if I'm a business person, I'm like, yeah, actually, I don't have to spend any money training anybody. I mean, this is awesome, right? But realistically, I think for most of us, especially if you're here, you or your employer sent you here because you're like, I want to learn something new, right? And I am concerned that it'll become less and less easy to find a developer willing to do Windows Forms or WPF as time goes on, because those technologies are done. And if I may, I worked, this was years ago, I worked for a company as a consultant, and they had a, what was it? Some sort of Pascal application that ran a key piece of their business. And they had found this one young guy that was willing to maintain that software. And he had them in a vice, because I mean, it was not easy. Well, nobody knew this technology even back then. And the fact that they found this guy that was willing to do it, so he would come into work and he would fix the bugs or whatever, and then he would take a nap under his desk. Because he's like, they can't fire me. Where are they going to find somebody else willing to do this crap? You know, and I think WPF and Windows Forms slowly but surely are going to, you know, and web forms too. I mean, this is their future, right? And so if you like the idea of being an indispensable person that can go in and take a nap under the desk, you know, there's your path. Anyway, Blazor and WPF or Windows Forms are also quite similar in a lot of ways. The big difference is this, and this doesn't really capture it, this captures the similarities, but the big difference is this, that if you are writing software, let's say you're in manufacturing, which I worked for many, many years, and you are writing software that needs to directly interface with manufacturing machines or something like that through serial ports or USB ports or, you know, whatever, specialized hardware, you probably can't get at that through the browser. Blazor runs in the browser. Therefore, you almost have to create native Windows apps in order to talk to that kind of specialized peripheral. Now, most of us are not in that. Anybody here in that case where you're, yep, yeah, right? And so, I mean, this is a real thing. In the second hour of this, you know, two-part deal, I'll talk about using what's called a MAUI hybrid. So you can actually create a native Windows app, and native Mac, native iOS, a true native app using Blazor. And so even there, you can completely get rid of Windows Forms or WPF. But that is a really valid motivation to say, you know what, I have to create a Windows app because of some, you know, this is not a traditional business app. This is something that requires extra stuff, right? So this chart now starts to get into the different ways that you can host Blazor. So when I did my little history thing, I talked about the fact that Blazor can run just purely on the server with this connection out to the browser. So it makes the browser into a really interactive terminal. So this is called Blazor Server or Server Interactive mode. There are some real advantages to this because all of your code is running on your web server, and the only thing that ends up downloaded and running in the browser is this small amount of JavaScript and then your HTML, CSS. And so the startup time to deploy, or you have, from the time the user clicks the URL to the time that they actually see something on the screen is very short. There are some drawbacks to it because it's a server-side web, so it can't run offline. You know, there's no client-side access to anything really outside of the browser sandbox. It scales okay. It scales to several hundred concurrent users without any real problem. I have talked to people that have managed to scale it to thousands of concurrent users, but that takes real specialized knowledge of how to make Azure work, because you need, it's complicated and expensive. And the reason being that this is all running on the server, right? And now I guess is as good a point as any for me to be crystal clear that when Blazor's running on the server, it is stateful, not stateless. So most of us that have done web development usually think of the server as being stateless, right? So every post back to the server could go to a different server and we don't really care because the server, right? Blazor does not work that way. Remember that Blazor sets up this pipeline between the client and the server, and literally as the user is typing and clicking up here, it's sending messages back to the server. That means the server is actively sitting here listening. So there's a real bidirectional connection. So every browser has a chunk of memory consumed on the server that is persistent. And you might therefore look at that and go, oh, well then Blazor sucks. And I hear you, but how many of you flew here? Most of us. And those that didn't, how many of you used a credit card to pay for something within the last week, right? Well, I will pretty much guarantee you that your flight data, your management of that, and your transactions for your credit card all went through stateful mainframes. The mainframe model, because that's really what we're talking about, is a stateful server that has got a smart-ish client terminal thing. Most of the world still runs, frankly, on the mainframe. And you know, we it's all invisible to us, but it was not that long ago. I live in Minneapolis, and so I was flying from Minneapolis to VS Live in Orlando, and I was sitting there. This family comes up, and they're like to the flight attendant. You know, we're waiting to board, and they come up to the flight attendant person at the desk, and they're like, "Hey, you know, I would like my kids and everybody to sit together." And I could see the screen just from where I was sitting, and she's clicking with this beautiful picture of the aircraft, and she's like, "Oh, I can't do it." And not to be ageist, I'm also old, but she waves to this older lady who comes over, hits some magic key on the keyboard, and it switched from this beautiful graphic display of the airplane into a green screen. She types in this long line of gobbledygook, hits return, and she's like, "Oh, yeah, you're all set." So she knew the dark magic is what I'm getting at, right? Or the deep magic. It's you know, behind all of these beautiful screens. What I'm getting at is don't dismiss Blazor just because it has a stateful concept to it, because a lot of the world actually still works that way. And for the most part, you know, Blazor, most of the people that I know that are building Blazor apps build at least part of it to be Blazor Server, and it works just fine. The next column here is WebAssembly. So you can build your Blazor app to be pure client side, in which case the only reason you have a server at all is to deploy the code. And so then what gets downloaded is your HTML, your CSS, the DLLs for .NET, the DLLs for your application, your NuGet packages, all that stuff gets downloaded. Now they're not, they're WebAssembly, right? They're not Windows binaries or anything else. These are WebAssembly binaries that get downloaded, and then they run in the browser, right? So at this point, you literally are running architecturally very much comparable to WPF because you're actually running on the client device.
Does your data get pulled down as well?
So the question is, does your data get pulled down? Well, that's your choice, right? That's no different than WPF or Windows Forms, where your code is running and then presumably you need data. So then you make an API call somewhere to retrieve your data. So you ultimately, some of your data gets pulled down, but not part of the deployment. That's part of your code running. Yep. So the advantage to WebAssembly is that it scales almost infinitely because all of your code's running on the client device, right? And so you're not consuming any central resource at all. So obviously you can scale to all the devices on the planet, theoretically, right? But the drawback is that there's a startup cost, because you actually have to download all these DLLs before the code can run. And depending on the internet connection speed and whatever, that might take a few seconds, right? And so there's a real drawback, especially for consumer-based apps. You know, most of us are like, well, if my employee has to sit and wait for 5 seconds or 3 seconds, every morning, what do I care? But if you're a consumer creating a public-facing website, 3 or 5 seconds, most of us move on. We're like, well, what a crappy website, So the third column tries to get the best of both worlds, and that's what I'm going to focus on here for the rest of the talk. Is what this is what came in Blazor 8, and it's called auto mode. And so auto mode starts with the server side because that gets something on the screen almost immediately. The user is using your app, and in the background, it's downloading all the DLLs. And then at some point in the future, when all the DLLs have been downloaded, it switches over to WebAssembly because that shifts the load off the server. So now you get the best of both worlds, right? You get this almost immediate startup, ultimately with the best possible scalability. And there is a little bit of knowledge and work that you and I have to make this possible. But a lot of the heavy lifting is actually done by Blazor itself. Right? So I think it's a very cool thing. And then the final column is hybrid, which I'll talk about in the second hour, but this is creating a native app using Blazor, but it's an actual native Windows, Mac, iOS, or Android app. So this is more something, you have these slides, and so you can use this. This is just a decision tree. You start with the black dot and say, do I want to be cross-platform? And if you don't, then all the Windows technologies are good for you. But if you want to be cross-platform, then do you want to deploy or need to deploy through the Apple and Google stores? That's a decision point. And then if you don't want to go through the stores, which most of us don't, then it becomes a question of, do I do Blazor Server only? Because honestly, that's the simplest, but it can only scale to 300-400 concurrent users without extra effort. How many of you have apps that need more than 400 concurrent users? Really? Well, let's be clear. Concurrent means they are logged in at the same time actively using your app. Usually there's like 3 people, and here I've got like a third of the audience. So wow, okay. So these are the architectures that are in Blazor 10. So let me kind of walk through this a little bit. So I left out this one on the first one here before, so now I'm going to really dive in, and then I'm going to show you the code, okay? So there is this concept of server rendered pages, or what are called SSR, server-side rendering. And so that's on the far side from me. And what happens there is exactly the same thing that happens with ASP MVC or Razor pages. So your code runs on the server. It does not set up a SignalR pipeline. Okay, your code runs the Razor pages, everything else, creates a bunch of HTML and CSS, and sends it to the browser where it gets rendered. Done. That's it. So it's the old-fashioned, not interactive style of web. Now, that turns out to be really valuable because if you've got a page that's just displaying some data, or a page that's just displaying a chart, you don't need interactivity, right? So why would you go through all the overhead to set any activity, why would you do that to yourself, right? You can just send the HTML, CSS, because literally you're creating read-only content. So that's option 1. Option 2 is server interactive, so Blazor Server, which we talked about. All your code runs on the server, but there's this persistent SignalR pipeline with events passing back and forth between the server and the browser. Right? So now you're interactive, but there's a little extra overhead because you got that SignalR pipe set up. Then there's Blazor WebAssembly, where all of the code got downloaded, runs in the browser. Still might call the server for APIs, but your code is running in the client. And then finally is the hybrid, where everything is running on the client device because it's an actual native app. The other thing that you can do, and I'll get into this next hour somewhat, is it's possible to create client-side only apps, like one tier. So in fact, you can put your data on the client device. So following the philosophy of start from 0, I'm going to open Visual Studio. I am foolish and live on the edge. So this is the insider's build. Don't worry, I'm not going to show you anything that's not in the actual build, but I worry because it may or may not actually work. All right, let's see. Create a new project. So, and let's just start here. And so if I type Blazor, so there are several templates that you might have in your Visual Studio for Blazor. The primary one is the Blazor Web App. That's the one I'll be using today. If you've got Aspire installed, there's an Aspire starter. There's the Blazor Server app. This is, you know ahead of time that you don't want to use WebAssembly. It's just like, I'm going to do a Blazor Server app. I'm going to create a Blazor Server app that is empty because maybe you don't want the starting example code. This one's actually quite important. For the most part, I always use Blazor Web App, right? Except if I know that I'm creating a client-only app, right, intentionally something that maybe runs offline on the client device or something, you would use the WebAssembly standalone app. And what this does is it creates a Blazor app that is designed to run 100% on the client device. Right? So this one can be a useful template for you. There's the WebAssembly app empty, very similar. Hybrid, a couple different hybrid options that I'll get into later. And then this final one down here, the Razor class library is important because this is a DLL that can contain reusable UI components. And so if you're working in an organizational structure where maybe you want to share a common login screen or any number of things like that, and you want to put that in a DLL that many different teams can use or different apps can use, this is how you would do that. And I use them pretty much all the time just to help myself organize my code. So what I'm going to do right now, though, is I'm going to pick the Blazor Web App, and I'm going to say Next. I get to give it a name, so Blazor App 13, perfect. And then let me zoom in here, because now I get a whole bunch of options on how am I going to set up my Blazor Web App. And so I get to pick the version of .NET that I'm going to target. I'm going to target 10. You could still use 8 and 9 for another year, I want to say. But at this point, you probably want to pick 10, right? Do I want to configure for HTTPS? And the answer should always be yes, you do. Security is a good thing. There's authentication type. And in the current templates, the authentication type is either none, which really means do it yourself. And I'll show you that in a little bit here. Or individual accounts. And so what are individual accounts? Well, since the late 1990s, I think, when ASP Classic came out, Microsoft has allowed us to run a script in SQL Server that would create a user database and then a whole bunch of UI stuff for like adding roles and users and logging in and out. Everybody knows this, right? That's what this is, right? So if you're using that scheme or you want to use that scheme, you certainly can continue to do that. If you've got Docker installed, you can containerize everything. This becomes the fun part. So interactive server mode, do I want my app to have no interactivity? So I'm going to create an app that is purely read-only, right? All it does is sends HTML, CSS to the browser, and I'm just creating a reporting app. I might actually pick none because I don't need interactivity. Or I could say, well, I want all my pages to be server-side pages, or I want all my pages to be WebAssembly pages. Or what I usually pick is this auto, right? So that's where it starts running server only and then graduates to running in WebAssembly. And then you get to pick, do you want that to be a global setting or a so for example, I could say, well, I want server only and I want it global. So all of my pages all the time are server interactive, or all of my pages all of the time run on WebAssembly. So these are all options, different combinations you can pick. What I'm going to pick right now is I'm going to say auto because I want all the good stuff, and I want to do per page because some of my pages I might want to be server rendered. Some of them I might want to run WebAssembly, any number of combinations per page. So then I'll create my project. And really what it's going to do here is it's going to create a solution for me. It's going to create the web server project, so ASP.NET Core, and then it's going to create a Razor class library that can be run on the server or could be deployed to the browser using WebAssembly. So it's a solution with 2 projects in it. And so at the top here, we've got our Blazor App 13. Blazor App 13 is an ASP.NET Core application. It's got a program CS. We'll walk through that. root with things like your CSS in it. Components. It could have controllers, right? All the webby stuff. And then there's Blazor app 13.client. This is actually a DLL. This is a Razor class library. And so it has some of my pages in it, such as the counter page. So if I run this app, it says, yeah, hello world, how you doing? And then, and so this is the default page, right, home page. And go to the counter page, and I can click the button, and it counts up. See, it's immediate interactivity. I can go to the weather page. I want you to watch close here, because what's going to happen on the weather page is using a basic web browser technology called streaming, but it's going to display a loading page and then display the data. And so Blazor has built-in support for this browser concept called streaming content, which is also really, really nice when you're displaying data that has to come from a database or maybe has many, many pages of data and you're loading it, but you want to show the user something immediately. And now I'm going to go back to the counter page, and I'll click and go up. But I want to tell you something here that you can't visually see, and that is the first time I went to the counter page, it was running in server interactive mode. So all the code was running on the server with this SignalR pipe. So every time I clicked, it was sending a click message to the server. The code was running on the server to increment the value and then sending a message back saying, hey, the value incremented. Now, because I've been on the weather page for a few seconds, in the background, it downloaded all the DLLs. And so I will tell you with high confidence that right now, when I click this button, it's purely running on the client. It's running in WebAssembly and it's not talking to the server at all. To me, this was invisible to the end user, right? But now I've shifted all the workload off the server onto the client. So pretty cool stuff, right? Another piece that I just, and for those that might not be using ASP.NET Core, the default when I'm running Blazor code is it's running in a web server called Kestrel. So that's what this console window is right here. This is actually the web server running. And you might say, wait a minute, how many of you still use IIS? Yeah, see, lots. Almost everybody. IIS is, no. The problem with IIS, the problems with IIS. I was going to say the problem is that it runs only on Windows. I haven't deployed anything to Windows for years. I deploy everything to Linux because it's cheaper. It's even cheaper in Azure, right? Microsoft's own cloud, per hour, it's cheaper to run Linux servers than it is to run Windows servers. And in modern .NET, because it's cross-platform, as a .NET developer, I don't care. It's literally no different running in Windows or Linux. And so why wouldn't I pick the cheaper option, right? But there's a whole host, of course, of other challenges with IIS. I mean, it's a technology created for the world that used to exist 20 years ago. And the world that exists today is primarily a world of containers running in Linux, running in Kubernetes, or any sort of Docker containers, all this sort of stuff. And IIS literally doesn't even work in the modern world. And this is designed to work in the modern world. It was built for the modern world. Although it's a whole tangent that I don't have time for, one of the primary reasons that Microsoft rewrote .NET from the ground up to create modern .NET versus .NET Framework is because of being able to run on Linux and run in containers. And there are other reasons too, but that's a big one. That's a really big one, because the modern world is container-based. Getting off my high horse. So if we look at the server, so this is the program CS. This is pretty typical ASP.NET Core. So we start out saying, oh, we're going to create a web application, right? And but then we say, okay, we're going to use Razor components. This is Blazor. We're using Blazor, and we want to use interactive server, and we want to use interactive WebAssembly. So we're turning on these features. And depending on those options, when I created the solution, some of, like if I said I don't want to use Razor, or I don't want to use WebAssembly, this would not be here, right? So it basically is turning on or off bits of code. And we build the app. So right here, this area is where you're going to add your own services. Things like, oh, I need to talk to a database, and so I'm going to create my entity framework DB context, or all sorts of stuff might go here. Come down through some boilerplate. Then we get down here, and I'm going to say, oh, we're going to use some static assets. This is what gives access to the www root directory, where I've got my CSS and my fave icon and any other static assets that I might have. And then here too, we're saying, all right, now I want you to look through my code base and find any Razor files. And I want to make sure that any of them that are set up to be interactive server are connected. Any of them that are set up to be WebAssembly are connected. Oh, and by the way, I've got this other DLL over here called Blazor 13.client. I need you to go, scan that as well. And so this is where it finds all of your Razor pages so that it knows. And what it's doing here, and this is important, is it's setting up the navigation. So not only is it identifying all the pages, but it's figuring out the navigation routes so that the user can actually go to those pages. The next thing that happens is if we go to component, there is a thing called app.razor. So app.razor is a Razor page. Okay, so this is rendered as part of Blazor. Now it looks like HTML. And I want to be clear here that Razor is a superset of HTML. Does that make sense? So in other words, all HTML is Razor, and then Razor adds extra stuff to it. But none of this gets rendered directly. So what you think of here as a head tag is actually a Razor component that renders a head tag. Kind of weird, but that's how it works, okay? For the most part, this is very subtle, but when we start to get into things like right here, this link tag, as we go over, has an @ symbol in it, and this says, oh, well, what follows this @ symbol, this is actually code that needs to be transformed into something else as it gets rendered. And so what we see is assets. Blazor is going to transform this assets thing that's bringing in Bootstrap, and it'll probably change the path and do a bunch of other things to make this actually work. You can also see that some of these things look kind of like normal, and then some of them are special color or bold in the editor. And these are actual Blazor components, or what are technically called Razor components. And so a lot of these that are here are built in. So this resource preloader is a placeholder where things can be injected automatically by Blazor. Same with import map. Head outlet, so on your individual page, you can add extra headers. So all of these all of this stuff is available on every page. But you might have a page that has to have an extra tag for SEO or any number of things. That will appear here when it actually gets rendered. Now we can go down into the body area, and here we can see that it's going to display something called routes, which I'll show you in just a minute. And then it also brings in what's called a reconnect modal. So one of the drawbacks for those that have been using Blazor for a while, that you might have noticed, is that if the user is on their phone and they drive through a tunnel, when they come back out on the other side, they may no longer be connected. They might have to log into your app again. Blazor 8, 9, and 10 each have added lots of features, now including this one, to try and reconnect. So the user drives through a tunnel, they lose connectivity, they come back out on the other side, and they're still trying to reconnect. And so Blazor, it's not perfect. I mean, eventually it gives up, obviously, right? But for that type of scenario, it'll probably successfully reconnect to the server, and the user can continue to work like nothing happened. So yay, right? This is a big deal. So routes. So I'm gonna, I could just go, but I'm gonna right click here, and I'm gonna say go to declaration. And so now I end up in a file in my project called routes.razor. And routes.razor actually brings in the Blazor router. So remember when I said it mapped all of your Razor pages, right? This is the thing that manages all your navigation. And so, and it by default says, well, if the user tried to go to a URL and we found the URL, then let's show them the end state of that route. Let's show them that page. And you can, if you want, put not found, and then you can have your own special content for, hey, there's no page here or whatever it is. You know, by default, it's 404, right? But you can override that. Right, so route view displays whatever the user is trying to navigate to, and if we go a little further over on the route view, we can see that it's got a default layout that says this is your default layout. And so again, if we look over here in our code, we can see a couple directories, a layout directory and a pages directory. And so in the pages, I've got like the home page and stuff like that. In the layout directory, I've got main layout. And so if we look at main layout says, oh, you know, we've got a div, we're gonna have a sidebar where we're gonna display the nav menu. We've got the main content area that's gonna have some sort of a header with an about link. And then here we've got an at body, which is the placeholder for every page. And of course, you can have multiple different layouts, and that's quite common for your main app to have a layout, but then like if you go into the admin section of your app, it might have a different admin layout, or you know, that sort of thing. None of this is new, right? This is just the way Blazor has done concepts that have been around forever. Here too, nav menu, notice that it's bolded, kind of a different color. So if I right click on it, I can go to definition, and we end up looking at navmenu.razor. In here, there's a whole bunch of stuff because it's actually using some CSS tie-ins and stuff like that. Query selectors, but ultimately it's a bunch of divs that have nav links. And so you don't have to use the default nav menu style or scheme. You can come up with your own, right? But they give us, at least by default, something to start with. And so, but now that you've seen this, let me run the code again, because I want to show you, at least by default, what comes out of the box using Bootstrap. And that is that if I shrink this thing, notice how the nav menu collapses. It disappears and reappears, so that if it's running on a phone, it'll still work, and then the nav menu becomes a drop-down, right? That's all part of the nav menu code. And of course, you can do anything you want. I'm just saying, you know, this is kind of nice as a demonstration of the capabilities of what Blazor does in combination with Bootstrap. And then you might say, oh my God, I hate Bootstrap, right? It's like the worst thing ever. I'm a Tailwind fanatic. And I have seen some beautiful Blazor apps that use Tailwind, right? There's nothing that forces you to use Bootstrap. It's just Microsoft had to pick something for the out-of-the-box experience. And they picked the most common technology, but you can use anything you want. All right, so then the next thing that gets loaded is the home page. Oh, look, here's a home page. Well, this too just looks like HTML. The only real difference is at the top, it says at page with a slash. And so what this is doing at the very top here is it's saying this is the route to this particular page. And in fact, a page can have multiple routes, and so I could have 2 routes. And so now it's the default route, you know, slash, but also if I do slash home, I can go there. And then this becomes important because, and we'll get into this, whoops, what did I do? We'll get into this in more detail, but I can do things like start passing in, or maybe I got that backwards. Yeah, there we go. I can start passing in parameters into my pages. So very, very common for a page to have multiple routes. Probably not slash and home, that's probably kind of silly. But the idea of having different combinations of parameters that you can pass in order to, like, you know, here's my customer ID or the customer name because we're doing a search, or all sorts of, you know, combinations like that.
Is there a limitation to how many parameters?
Is there a limitation to how many parameters? And I'm sure the answer is yes, because eventually you run out of, there's a maximum size on a URL. But Blazor, to my knowledge, doesn't have a hard limit, no. Here too, we can see page title is one of these special tags. This is a built-in Blazor one, but what that does is it coordinates with the browser itself to set the browser's tab title and that sort of thing. This is just an H1 tag and just some text. If we look at the weather page gets a little more interesting. So the weather page says, my route is /weather. I'm going to be streaming, because remember how weather loads. It comes up and says loading and then displays the data. So this attribute tells Blazor, we intend for this behavior. This is what we want. So here's my title, my header, some text, and then we do some razor stuff. So we say, oh, well, if I don't yet have any data, I'm going to display the word loading. If I do have data, the else, then I'm going to create a table, and as I create the table, I'm going to use a for each loop to create each row. Now I have to laugh just a little bit here because I've been doing this for a long, long time. And so when the browser, the whole HTML thing started up, we all used table. And then all of the graphic web designer people were like, oh, you should never use tables, you should use divs for everything. Because it's better to use divs to create tables than table. Well, now we've come full circle because it turns out that semantic text readers can't differentiate the div stuff, right? So accessibility and HTML5 says, no, use table because that actually has some real meaning, whereas a div does not. And so I think it's just, I think it's funny how things come and go. But if we look here, so let me shrink this just a little bit because we've got this for each loop. So the @ symbol here says this is about to be code, right? So this is telling Razor this is about to be code, execute this code. And then here we're saying we want to, this is code. So forecast.date.to short string, that's C#, right? And so I'm mixing. And so for those of us that have been doing this for a long time, I think we've all fallen into patterns that we know work. If you haven't been down this road before, right, if you're purely coming from a Windows Forms, Web Forms background, this can look really scary because it violates all sorts of principles, right? Because you're mixing UI code with code, right? The HTML and C# are like literally intertwined. And it turns out that's fine as long as in here you avoid putting any business logic, right? All of the C# that goes into a Razor page should only be there to render the page. Any actual logic ought to be somewhere else. And by somewhere else, I mean in a business object or a business library, or there's a whole host of different strategies for that. But it is a slippery slope, right? And you can create totally unmaintainable code by writing all of your C# business logic in your Razor files. That can be a real disaster, so don't do that. Now we get to maybe the most controversial part of this whole thing, and that is that there's a code block down here. And by controversial, what I mean is that right there, that should be on its own line, damn it. I mean, yes, that's controversial, but actually what I mean by this is, so this is the code. So pages have a life cycle. And one piece of the life cycle, perhaps the most important or commonly used, is the onInitialized event. And this is what happens when the component gets initialized. And so this is usually where I'm going to go out and load my data. Now in this case, it's fabricating some fake weather data, but literally this is the place where I would talk to my database, right? Or call a remote service to get the, call an API, whatever it is, this is where I would do that to get the data. And so what's going on here is it actually simulates a half-second delay to talk to the database, right? And then fabricates some data. And so a lot of people will look at this and go, wait, this should be code behind. This is actually the controversial part. And this is code in line. Well, here too, just a titch of Blazor history. So Blazor started with code No, maybe it started this way. Oh, I don't remember. At one point, Blazor used code behind by default. And a bunch of React type developers said, wait a minute, that's primitive, ancient. You're adding extra files for no good value. And so Microsoft backed off and said, okay, fine, we'll make this the default. But that turns out to irritate most of the Windows Forms, Web Forms, WPF people who are like, what do you mean I'm putting this code in the frickin' same page? It should be in a separate. And so luckily you can go right click here and you can do quick actions and refactorings. And then I can say I would like to extract block to code behind. So it's a refactor. And so now if I look at my Solution Explorer, now I've got weather.razor and a separate weather.razor.cs code behind. And so now some people have and so if I look at the razor, if I look at the very bottom of the razor, now that code is all gone. Everybody can breathe a sigh of relief. And I can go here and now it's a public partial class, just one sec. And so all of the same code is here in code behind. And so now you might, next question, and I'm going to anticipate maybe your question, well, could I make that the default? And the answer is no. You should pressure Microsoft if that's a concern. For me, I've learned to love and embrace the code block. So I actually don't do this myself. I just leave the code the way it is. And my motivation here is that I should have very little code in the code behind anyway. Right? If I'm putting lots and lots of code in the Razor page, in my opinion, I'm doing it wrong. Right? Now that said, if I'm on a team with a bunch of other people and as a team we decide to do it this way, I will obviously do it this way because consistency within a code base always wins. Right? It's a team decision which way you want to go. That's my opinion. So now we'll look at the counter page. So the counter page is the first page that's interactive. So just to reiterate, let's look at home. At the very top of home, I have a page directive, okay? And if I look at weather, at the very top of weather, I have a page directive with the streaming attribute. But if I look at the counter page, I have a page directive and then I have a render mode. The default render mode is server-side rendering, which is to say no WebAssembly, no SignalR. We just create HTML, CSS, and send it to the browser. That is the default. And so here what I'm saying is I want interactive auto. And my options, in fact, are interactive server, interactive WebAssembly, or interactive auto. And I already talked about those, so I'm not going to rehash that, but hopefully that makes sense to you. So I get to pick which mode I want this page to run in. So by saying interactive auto, what I'm saying is I want you to render first using interactive server. Once the DLLs are downloaded, I want you to render in WebAssembly. Because this is an interactive page, now I can have a button that has an on-click handler. Note that it's an @onClick, and it's saying when the user clicks this thing, I want you to run the increment count method. And oh look, here's my increment count method. And the reason this works is because I'm an interactive page, right? Everybody with me so far? Yeah.
So we didn't need to specify on the whether or not like the okay, because the default does serve that, right?
We didn't need to specify on home or weather because neither of those are interactive. And the default is server-side rendering with no interactivity.
So one of the interactivity, you access at render interactive server.
Correct. If you want interactivity, you need to have an @render mode on it. Yep. And this is one of the most common early bugs that everybody encounters with Blazor is you forget to put a render mode on, you start doing a whole bunch of interactive stuff, you run it, it renders, and then you click the buttons and nothing happens. It's like, what the heck, what's going on? And it's like, oh, I'm not in interactive mode, so therefore my buttons do nothing. That will happen to you. Don't be embarrassed, it happens to everybody. Luckily, the AI is really good at detecting that. So if you're using Copilot or Claude, they will go, hey, they will do it very politely. But the subtext is, hey, dummy, you forgot to put a render mode. But notice how this works, right? Is this not elegant? Because we just have a numeric value, could be a string value, whatever. Up here, we are displaying current count. And then here, when we click the button, we just increment it. And by elegant, what I mean is there's no property changed or on property changed. All the stuff that we've mostly had to deal with for decades now, all that is gone. And you might say then, how does that work? But this is the final like basic thing to understand about Blazor. How does Blazor render? Then we'll take a break. Then we'll come back after the break, and they're going to go through a whole host of much more advanced things: authorization, authentication. Basically, I'm going to assume, hey, we're all at least up to speed on the basics. Let's look at practical stuff, right? So what happens is that Blazor, in memory, maintains a copy of what it thinks is displayed in the browser at all times. And that's either on the server or on the client, depending if you're in server mode or WebAssembly mode, okay? And so when this current count plus plus happens, as it exits this method, Blazor's like, oh, the user clicked a button, I ran this method, the method probably changed something. So when the method exits, what I'm going to do is re-render the page. And so now it's got two copies in memory of what it thinks is in the browser. This is what it believes is on the browser. This is the new rendered version. Then it compares the two, finds any diffs, and sends the diffs to the browser to be re-rendered. So it only literally re-renders just the values or pixels that changed between those two diffs. Does that make sense? It's not actually pixels, but it's the HTML DOM elements that changed. And so on one hand, this is really elegant because it means we as developers don't have to do on property changed or anything else because it's just magic. On the other hand, you might imagine, and I've seen this many times, that people write stuff and they're like, oh my God, it takes like 2 minutes to do this trivial thing in Blazor. Why is it taking 2 minutes? This is a real example. And we looked at the code, and they were in a for loop that was causing a re-render thousands of times as they were processing stuff. And it was re-render, right? It was doing this and the diff comparison. And it's like, no, what you really want to do is turn off the render mode, because you're like, I know that I'm in a loop that's going through several thousand things. Tell you what, how about if y'all don't do any rendering? We'll just do the loop, and then at the end, I can call a method called state has changed and tell you that we're done. And that forces a re-render, right? And so to do that specifically, we get into another life cycle thing. And so override. And so if we look at the override options, yeah, that's big enough to see, I think. There's initialized and its async version. There's parameters set and its async version. We'll get into that in a little bit. That has to do with data binding. There's on after render and its async version. And that primarily has to do with JavaScript interop, honestly. But then there's should render. And so if you're in one of these cases where you're doing some sort of a loop, what you do is override should render, just set a Boolean flag. So it's like, hey, I'm in a loop, should render returns false, right? So then Blazor says, should I render? No, 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 no. And in the case, literally we added like 3 lines of code. You see what I'm saying, right? 4 lines of code, and went from 2 minutes down to maybe like 1.5 seconds. Because there's so much work was involved in the re-render and compare. It can be remarkable. And so understanding the life cycle and the rendering process that happens is really quite important. Does that make sense? All right, so now it's time for a 15-minute break. We'll come back, and like I said, now I'm going to go through how to talk to databases, how to do authentication, and a whole bunch of other just practical, like in order to really use Blazor, this is what you need to know. So I'll see you in 15 minutes. Welcome back, everybody. So now I'm going to finish one thing in this demo that I want to make sure I cover, and then I'm going to start talking about a couple other topics. So, but the thing that I want to talk about is there's this concept that we've been dancing around called render modes. And so we can, right here, and I've actually got a piece of code that I'm just going to copy paste. You can, at runtime, know what your render mode is. And so let's run this thing. Now you're going to have to watch closely because this happens quite rapidly. All right, let's make it bigger. There we go. So I'm going to go to the counter page, and now it should display the render mode. And so what's going to happen, the auto render mode that came into Blazor 8 and 9 and 10 has a philosophy. And the philosophy is we want to get number one, show the user content as fast as possible. That's priority one. Priority two, ultimately get to WebAssembly, because that's the most scalable option. So number one, show the user something that they can see. Number two, get to WebAssembly. Okay? But number one, so how do we show the user something that they can see as quickly as possible? Well, it takes time to set up a SignalR pipeline. It takes even more time to download the DLLs. So the quickest possible way to get the user to see something on the screen is server-side non-interactive rendering. So by default, what happens is every time the user goes to a page, the page renders in non-interactive mode, then switches to interactive mode. Now this usually happens sub-second, so it's going to happen really quick. So I'm going to click on counter and just watch right around this part of the page here. You'll see what's going on. Did you see that? It said, is interactive false? Now is interactive true? That was pretty damn quick. However, this is all running on my computer, right? So now imagine that, and I've worked in agriculture off and on over the years. So now imagine that you're building some software that's going to talk to a farm in the middle of Montana. And they're using DSL because that's still state of the art in the middle of nowhere, Montana. And so this might actually have, taken a second, like literally, because there's that much latency over, or maybe they're using HughesNet satellite, right? Which has, those are high orbit satellites, not like Starlink, right? And so there's actually the speed of light comes into play. The point is, there are real cases where switching from the one mode to the other might take half a second or a second. Well, the thing is, until this says interactive true, the button won't work. And so if you're in a case where it could take a little while to become interactive, you actually need to do something because the user might start typing into a text field and then their entry disappears. Or they might be clicking on the button and it going, it's not working. Oh, it worked. And then after a while, they get really pissed because they're like, this software is just super unreliable. Half the time I have to click the button 5 times. You see what I'm saying, right? It's a bad user experience. And so the way that you defeat that, well, there's a couple ways, but the way to defeat it, the simplest solution is to say this: if renderer info dot is interactive, right? And now let me rebuild this because this has been a bug in. Like I said, I'm using Visual Studio Insiders, and some bugs happen. So I'm doing a hard rebuild in the hopes. Anyway, so see what this is saying. It's saying, if I'm interactive, I'll show you the button. If I'm not interactive, I'm not going to show you the button. right? So now let me run this code and watch what happens. So again, let's zoom in here. So again, watch when I click counter. See how the button appeared only after I'm interactive. So now the user couldn't have made a mistake, right? So now I've given the user a much better experience, right? Notice too that I'm in server mode here, right? So now if I go out to another page and I'm sitting here doing whatever, in the background this DLL is downloaded. So now it should be, when I go to counter, again, notice that it went into server render mode, non-interactive mode, but now when it switched into interactive, notice that we're now running in WebAssembly, right? And so this is important because this allows you as a developer to understand the mode and react accordingly. And you want to in order to give the user a good experience. So there's another solution here, and that is that you can turn off what's called server pre-rendering, because that's what's going on with that non-interactive. In that case, the user just sees a blank page until it flips into interactive, right? Personally, I prefer to do what I showed you, right? Show the user something. And in fact, what I will often do is, well, let me move on to my next demo, because I think it might actually have what I often do. So let's go look at some data access, shall we? So this is more real, still demo code, right? So if I say I'm going to list people, right? So now I'm listing some people. So this is actually talking to data, right? And if I say I want to edit somebody, oh, see that flicker, right? This one does not do what I normally do, but you saw that flicker, right? So that was the point at which it became interactive. This is bad code, bad Rocky. And 38, no, I feel young today. I'm 28. We'll save that. But so let's actually look through this code a little bit. Very similar to the basic demo in that what I've got are two different projects. We'll ignore the fact that that's bugging us. Got the web project, and we've got the client project, but there's more here, obviously. And so let's look at the web project a little bit, because this is, again, more typical of something you might see in real life. So I set up, the Blazor stuff. In this case, though, I'm using SQLite. You could be using SQL Server, Postgres, whatever, but I'm using SQLite. So I'm using dependency injection to get database connections. And so if you're not familiar with dependency injection, you need to go learn at least the basics of dependency injection, because Blazor is the first UI framework that is absolutely built on top of dependency injection. You can't do Blazor without dependency injection, right? Every prior, even ASP.NET Core, which integrates dependency injection tightly, you can actually technically use ASP.NET Core without dependency injection. But Blazor, you can't. They're inherently coupled. But that's okay. It's generally a net positive. So what I'm doing here is I'm saying I want to be able to get at my database connection, and I'm going to use what's called a transient service. So in dependency injection, there's 3 different models. Transient, which means every time that you ask for one of these, you get a new one. Scoped, which says that every time you ask for one of these in a given scope, you'll get the one that already exists, and if one doesn't exist, I'll create it for you. And this is important within ASP.NET Core, because every request to the server in ASP.NET Core gets a scope. And this is true for like Razor pages, MVC, everything, okay? So when the request comes into the server, ASP.NET Core creates a scope, and then all your stuff can run. And so sometimes scoped is the right thing for a database connection. Because if you do a whole lot of database work inside of one postback, for example, you probably want to do it all on one database connection. And so you might say, oh no, instead of add transient, I actually want this to be add scoped. Does that make sense? right? And then when the scope goes out of scope, yeah, however you say that, when the scope ends, right, the request ends, everything on the scope gets automatically disposed. So it's super nice because it closes your database connection or returns it to the pool. So you don't even have to do anything by hand, right? It's like, woohoo, super nice. And then the third option is singleton, if I could spell. And a singleton there's one per process. And so this is, if you do a singleton, there will be one for all users on the web server. Right? So you have to be careful with singletons because that can be a source for data leaks, right? Cross-user data leaks, because there's literally one for the entire web server. In my case, I'm keeping my life as simple as possible. And so I'm using transient, just when I get a connection. But notice that I get the connection with the data source, I open it, and then I return it. This is, and I've seen different arguments here. Should I return an open connection or should I return a connection that you open? Again, I don't want to get into dogmatic debates. I personally always return open connections because that way my code, I just, if I got a connection, I can use it, right? Where does the close happen? The close, I rely on the dispose to do the close, right? So in the case of a transient, as soon as I'm done with it, it will get closed. Right? Here, I think I might be using entity framework, so I'm doing that, and I'm using a repository pattern. So I'm saying, hey, let's if we look at this person DAL implementation, the person DAL requires the connection. So this is how dependency injection chains on top of itself. So in my code, all I'm ever going to do is say I need a person DAL, a data access layer for people, right? The data access layer for people says, well, I can't do anything without a database connection. And so my page is going to get the iPerson DAL, and the person DAL is going to get the connection. And then in here, I can just write, oh, and I'm not using entity framework, but I could be, right? In here, I'm just doing simple insert, deletes, whatever else, standard ADO.NET code. And I've got a whole rant on entity framework that I'm going to just bite my tongue because we don't have time. I very frequently do this because this is the fastest way to talk to databases. And in a world of AI, AI generates this code just as well or better than it does entity framework code. And so why wouldn't I let the AI generate fast code? That's Rocky's short rant. All right, moving on. If we then look, for example, at components and pages and person list. So this is the person list page. Notice it does not have a render mode because I'm just listing people. It's read only, right? So I don't need all that overhead. But I do inject the person DAL. And by injecting the person DAL, of course, now we know that we're getting the database connection, right? I'm also injecting something called Navigation Manager. This is a Blazor built-in component that allows me to navigate via code to other pages, right? I'm saying, and this is, you'll just see this, every page that has data has some variation on this, right? If I don't yet have the data, show the word loading. If I do have the data, render the data. And here, so I'm rendering an add person link. And then I'm using another built-in Blazor component called Quick Grid. Microsoft didn't do this initially, right? They came out with Blazor and they said, hey, if you want to grid, use a table. And a lot of people, like all of us, were like, well, at least give us a basic grid, for heaven's sakes, right? Because you can go buy grids or get them, right? There's a ton of open source grids and Telerik and Telerik, however you pronounce that, and Grape City, which now is Meniscus or whatever they're called. There's a whole ecosystem of controls out there for Blazor. But at least Microsoft gives us a very basic grid. If you want a good grid, go look at one of those vendors because they have much better grids. But at least now we can say, okay, look, I need a column to show the ID, last name, first name, age, I need a column with an edit button. I need a column with a remove, or not button, but link, right? So it's fairly straightforward. You can see that the grid is bound to my person's list. But because the grid does filtering and sorting, it needs to be as queryable, because that's how the grid does its work. So this is I think this is a nice, simple little control, right? Now in my code behind is very simple. And this is why I generally don't personally bother with code behind, because I work really hard to keep as little code in the code behind as possible. So it's like, what do I care, right? This is the data binding object. And then in onInitialized async, I'm going to call my data access layer and tell it to go get people, right? And so we just looked at this code, right? So behind the scenes, we know that get people async uses a SQL statement against the database to get to the data, right? But look at how elegant this is in my page, right? I think this is very slick. Notice a couple things to notice. This particular Razor page is actually in the web server project. That's because it is a server rendered page, right? In other words, it doesn't have a render mode up here at all. And so it doesn't matter where this particular .razor file is, because it's always going to run on the server, right? Contrast that, if we look down here, I have person edit.razor. Person edit.razor is in the client. So it's in the Razor class library DLL. And that's important because this one is, well, right now it's set to interactive WebAssembly because this is a demo. Normally this would be set to interactive auto in my life, right? But the point is, it has to be in the DLL because sometimes it might render in WebAssembly. And the DLL can be downloaded to run in the browser. Does that make sense to everybody, right? Notice this page also has two different routes. This route is the add a new person route, because I didn't give it an ID, so this page will assume that we're adding a new person. Or I did give it an ID, in which case it assumes that we're editing an existing person. Now, you don't have to do it this way, but I do all the time, because almost always the add and edit pages are the same. And why would you literally maintain the code twice when, I can just reuse it? Again, it injects the person DAL, the navigation manager. In this case, and I do this pretty consistently, near the top or bottom of my page, I will put some sort of an error tag that binds to just a string. And if the string is empty, this doesn't appear at all. And if the string is not empty, presumably because something went wrong, then the user sees something in red text saying, couldn't talk to the database, the network's down, whatever it might be. Same pattern here, no data yet. So here's how I'm going to fix this problem, though. You might recall I was embarrassed because, let's put this back to WebAssembly. I was embarrassed because, of course, it flickered. That was bad, Rocky. So if we don't have the data or renderer, renderer info. Oh, is this running in .NET 9? Have I not oh no! Oh no! No wonder it's crappy code. Well, here, I'll just show you what I would do, because I'm not going to upgrade it to .NET 10 live on stage. I would just do this. So if we don't have the data, or we're not interactive, so now what would happen is that the user would see loading, it would flip into interactive mode, they would still see loading until the data showed up. And that way there's no flicker, right? Another thing that I'll do pretty commonly in real projects, instead of saying loading, is I'll have one of those like gray little document animations that are placeholders that's like fading in and out gently, because it's like, oh, you're about to see data, you're about to see, that's UX design stuff. But I'm just saying, those are all options. so then we come down, and here's another concept that's kind of cool. So Blazor has this idea of an edit form. And an edit form is designed to make it easy for you to create edit forms. Go figure. And so an edit form binds to an object or a collection or whatever, but usually an object, sorry. And then there's several different things. So there's on submit, on valid submit, and on invalid submit. So this ties in with the data annotations that's been around since .NET 3.5. So it's pretty nice. You can just attribute your properties. This property is required. This one has a regular expression. You know, all that stuff. You can just attribute your properties on your object, and it will just work, right? And so what's pretty common is to only handle the valid submit. So the user can't even click the submit button, well, they can click the button, but you don't get the click handler, right? You and I don't have to worry about it until the data is valid, right? You can, if you want, do your own validation, etc., but this is pretty common. Then in here, this is key. This is what turns on the data attribute validation. This displays the validation summary. So like the old, you know, like the laundry list of things they did wrong shows up at the top of the page, right? But and then I've got these text edit, number edit things that I've created. So this is one of the key, most cool features of Blazor, of the Blazor framework, in my opinion. And I do this all the time in all of my apps. And so if we go look at text edit, so I'm going to hit F12 here to go to the definition of this. Text edit is another Razor component that I wrote. And it does a div, it does a label, it does an input text control, and then it does a validation error message display. So basically what I'm saying, or have said in this app, is everywhere that I enter text, it's going to look just like this, okay? And so if somebody comes to me and says, hey, you know, Rocky, we need to change the way the text edits look globally, how many places do I need to change it in my code? Exactly one, right? This is a maintainability thing. Totally awesome, right? And then input text is a, so I hit F12 there. This is a built-in Blazor component that does the edit text. And really, if you dig into that, it is an HTML input tag, but with some extra things to make it friendlier, right? But ultimately, oops, I didn't mean to go all the way back there. Ultimately, edit text says, okay, you know, class, blah, 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 but we're binding to the text property. And that's what we're going to display. And so if I also go back here and look at number edit and hit F12, same thing, only now I'm wrapping input number, right? But I'm displaying a label, then the input, and then a validation summary. And so if we run this code, assuming I didn't break it, I did break it. That's unfortunate. Oh, yep. You're right. I left that wherever I left it. There. All right. So I'm pretty sure. Right, so let's zoom in so you can kind of see that. So I click the save button. My code still didn't run, right? Because clicking the save button, it's not valid, therefore my code didn't run. But Blazor, the edit form, did run and it validated everything. And so you can see here, this up at the top is that validation summary, and then each of these are the validation field. Now, I almost never actually do the validation summary myself, right? This is a demo. I want you to see what the options are, right? But I personally prefer to always have the validation in line, because that's, I think, a better user experience, but that's UX is somebody else's problem, not mine, right? But see, that's pretty nice, right? And so then if I fill something, something out here, random age, and then click save, then it works, and then we can see that Mary Smith is now in my list. And then I can click remove. Remove goes to another interactive page, says, here's the data. Are you sure you want to remove this person? So again, not a complicated thing, but this is definitely enough that you should be able to look at this code and go, oh, I understand how to do basic data entry, database interactivity stuff, right? Any questions on that? Maybe the one obvious question is, well, I don't know what I've got in my notepad. Hey, Rocky, where would that code be? And that's where all the code that I'm showing you here today is in that location. That's actually a hands-on lab that I use periodically to teach Blazor. And so there's actually a ton of stuff in there beyond what I'm showing you. So now let's go have a look at authentication. So Blazor authentication and authorization rests on top of ASP.NET Core, for one thing. So first off, Blazor itself doesn't implement any sort of user authentication. It sits, again, on top of ASP.NET Core, which is good because ASP.NET Core's authentication model is well tested, right? I mean, I feel confident using it because it's used all over the world by all sorts of companies and organizations and whatever else. And so it's been through the ringer. And I'm going to show you two different things. The first one I'm going to show you is the underlying technology in Blazor to deal with user identity, right? This is like the building blocks. And then I'm going to show you an Entra ID login, so using Microsoft's Azure login, right, with OAuth. And the way that that works is very similar to if you were using OAuth with Google or Facebook or anybody else. You know, OAuth is a standard, so they're all very, very similar to each other. But I'm going to show you the Microsoft version, okay? But I think it's useful to understand first, just like what are the basic things you have to do inside of Blazor to turn on all the features by hand. And so to start with, we'll go to Program CS. And I know that I want to add some security to my application. And so in order to do that, I know that I'm going to need to use the HTTP context because that's where ASP.NET uses HTTP context in order to manage your login and logout. So I turn that on. Then I turn on authentication for ASP.NET Core and say that I would like to use cookies. This line of code that I have highlighted, oh my goodness, people, that can be massive, right? And literally there are books with entire chapters on how to configure this. So and those of you who have done it, of course, are well aware that ASP.NET Core has lots of different options on how to manage user tokens and all this sort of stuff. This is the simplest model that I'm turning on. But you can turn on all the features if you want to, right? This is a Blazor feature. So this is, I'm telling Blazor that I am going to cascade the user identity throughout the entire UI. So all of my pages will have access to the user identity once the user is logged in. So cascading authentication state, okay? Then I'm adding a user validation service. You'll laugh when you see this because this is a demo. But this service is where you would check, like if you've got your own custom database or you're using an LDAP server or whatever, this service is the place that you would verify the user's credentials, right? Their username, password, or whatever it is that you're verifying, this is where you would do that. And then we go down a little bit further, and this is the other piece for ASP.NET Core and Blazor. I'm saying I'm going to use authentication and I'm going to use authorization. So once the user is logged in, I'm going to turn on and off different UI elements based on the user. Right, so that's that. So then we'll go to app.razor and just kind of look here. There's nothing different here. Then but this is like, I'm just walking through the steps, right? Program CS goes to app.razor, app.razor goes to routes.razor. Routes.razor, now I have surrounded all of routes.razor with cascading authentication state. So I turned it on in program CS, and now here I'm surrounding everything that renders in Blazor will now have access to the current user authentication state. Okay? The other thing that I've done is I've changed, normally or by default, this just says route view, but I've now changed it to say authorize route view. And so what that means is that if the user is not authorized to go to a page, they'll get a 404. And you might say, wait a minute, 404, shouldn't they get, what is the security one, a 403? 40, anyway, 401. But this is intentional that it defaults to 404 because if a bad actor attempts to navigate to a page and you return a not authorized result, now they know that the page exists and they can continue to attack it. Whereas if they try to go there and you return a 404, they're like, oh, that page doesn't even exist, and hopefully they move on. So you can argue that the 402 or whatever it is that's not authorized should never ever be used because it leaks security data. Anywho, all right, so then let's look at my layout. So my main layout has my sidebar with my nav menu. Oh, but now this is new and interesting. So in the header, I'm using a thing called authorized view. So this is the primary way in Blazor that you can turn on and off different UI elements or chunks of UI based on user identity. And so this one is the simplest version and says, is the user logged in or not? If the user's logged in, now we don't care their role or anything, it's just are they or are they not logged in? If they're logged in, we'll say, hello user, here's a logout link. If they're not logged in, we'll show them a login link. Right, very simple. Notice I'm just using href tags, right? And so I'm saying, well, to log in, we're going to route you to the login page. And so that, in my mind, implies that somewhere over here in the pages, there must be login.razor. Oh, look, there's login.razor. No render mode. This is important. The login page is going to use HTTP context. In order to safely use HTTP context, you must be in a non-interactive page. Interactive pages, it's not safe to use HTTP context as a general rule. Does that make sense? This is just the way it is. And so this page is not interactive, therefore I can use HTTP context. And so if we go into this page, I'm getting the username, I'm getting the password, right? Notice that I'm using the edit form control in a non-interactive page. This is a special Blazor control, so edit form can work in a non-interactive page. It works differently than it does in an interactive page. So the Blazor team did a clever little thing here. So in non-interactive page, what happens is the edit form control literally renders an old-fashioned HTML form concept from like 1997. You follow me, right? And so you have to actually tell it some things. You have to give it a unique form name because when it does the post back, because I mean, we're talking, really old tech here. When it does the post back, it has to know the name so it can connect them. And then it knows the method that's going to get called on the post back. And so I get the username, I get the password. We go down here a little bit. On the post back, it's going to supply the parameter from form because this is not Blazor, right? This is old style 1990s era stuff, right? So it's going to translate the form post back into my user info object, which is nice. Then it's going to call login user. I'm going to validate the user. So my user validation.validate user. Let's see if I go there. What does it say? This is super secure, right? If the username equals Yeah, it's horrible. Anyway, the point is this code right here is where you would talk to your database to really verify the credentials. This is a demo. I'm not claiming anything else. Assuming we get back, that yes, the user is real, then we create a claims identity. So .NET from .NET 1 has had this concept of an I principal and I identity. That's evolved over the years. In ASP.NET Core and Blazor, the only identity thing that works is claims identity. So if you have custom I identity implementations or whatever, by the time you go to Blazor, you will have to have shifted those to be claims identities. Right. For most people, it doesn't matter, but for some of us, it has mattered. So I create a claims identity, then I add some claims. So for one thing, I'm saying, well, my username is this. Then I call a method called getRoles, and I get the user's the roles for the currently logged in user, and I load all of those roles. And so notice what I'm doing here is that I'm creating new claim objects. A claim object has a claim types. A claim type is actually a string. So, and by convention, it could be Lhotka.net, my claim. But by convention, it's a URI, but it doesn't really have to be. It's just got to be a unique string. But there's a bunch of pre-built things here. So the claim types list has just a whole bunch of, and these are standard, right? These are not Microsoft or .NET specific. So the value of using these is that almost any claims-based authentication system, whether from Google, IBM, Microsoft, everybody pretty much understands that these can exist. You don't have to fill them all out, but you can see, name and home phone, work phone, street address, all sorts of stuff could be in here. And these are all things you can use to authenticate, or once you've authenticated the user, you can use these to authorize. And so, for example, you can say, well, this data is only available to people in Europe. Right, so most of us build everything just based around roles, which is fine. I'm not saying that's bad. But claims allows you to go way beyond that. So you can use roles, but also you can say, well, this is only available to admins that are in Georgia or something like that, right? Or in the US West region, sales region, or whatever it might be. You can be very, very fancy with that. And then ultimately we create a principal that contains the identity. So this is the user, this principal represents the user. Then we ultimately use HTTP context to tell ASP.NET Core to sign in the user, which creates the cookie and puts it out on the browser. Woohoo, right? And at this point, the user's logged in, the ASP.NET Core and Blazor middleware all do their jobs, and so the user's logged in. If we look at the log out page, it's even simpler because all it does is call sign out, which invalidates or deletes the cookie, right? So this is pretty cool, right? Hopefully. And the reason I'm showing you this is because every time that I talk to people, there's some reasonable subset, anywhere from 10 to 50% of the audience that has their own security databases. And then everybody else tends to be using OAuth, right? From Entra ID or whatever. But here's the thing, right? So when I run this app, I can click the login button. I can type, and you can see here because it's a demo, we'll do admin, and admin. And now I'm logged in. No, go away. Let's see, now it says hello admin, and I can log out. But now I can go for here example, and I can see this particular page is introspecting my current identity, and so it's like, oh, you've got to claim that your name is admin, that you're authenticated, and here literally I'm just dumping the claims list here. So you can see that here's the name of the name claim, and here's the role claim. And so my name is admin and my role is admin. Right? So I can see all of these things through my code if I feel the need to. Right? So I'm walking you through all of this because when I show you the Entra ID thing, it's going to have a lot less code, and that's because we're using a NuGet package from Microsoft that does exactly what I'm showing you here, just against Entra ID. And if you log in with Google or Firebase or something like that, you're going to use a NuGet package that does exactly what I'm showing you here, but they wrapped it up in a NuGet package. Does that make sense? So I'm showing you the underpinnings of what's going on. So there's a couple other things to show you here before I move on. And that is that if we look at the another page, I have a thing here that I wrote called user display, just to be fun. And if we look at user display, so I'll hit F12 to go to this definition. This way I can user display anywhere I want, right? Because I've created it as a reusable component. And so this is an opportunity too. This is a .razor file, but notice that at the top it does not have a page directive. And so here too is a really important concept for Blazor, and that is that .razor files contain Razor UI stuff. They're only directly routable if they have a page directive. If they do not have a page directive, then they're just a reusable UI widget, right? But what's interesting is that even if they do have a page directive, they can still be a reusable UI widget, which is kind of weird. But if I go back here, I could, on this page, add the counter page as a reusable widget. Does that bend your brain? Right? Just because it has a page directive does not mean you can't reuse it everywhere. It just means that because it has a page directive, the user can navigate to it directly, right? So the flexibility here may be a little extreme, is all I'm saying, right? But here, what I'm saying is I'm going to inject, and you'd almost never have to do this, by the way, right? Normally, if you want to deal with user stuff, you just use authorized view and authorized or not. But if you really want to, you can inject the authentication state provider, which is the thing that gives you access to the current user identity. Right? You normally never have to do this, but you can if you want to. Right? And so here, because I've done that, now I can actually, oh, there it is. Now I can actually go and get all these details because I literally have the claims principal and claims identity that I can do whatever I want with them, right? But normally what you do is just say, okay, if you're logged in, you get to see this, right? Or you can say something like this. So you can say, if you're an admin, you get to see this, right? Or maybe if you're an admin or a super user, you can see this. And so you can actually start, and these can be nested, right? So you can do all sorts of cool stuff. There's authorized, but then there's also, and I don't know if it's in here, yep. Then there's also the not authorized block. And so, and then what's the other, oh, before I forget, the other thing you can do is up here, you can put an attribute of, there we go. Let's just throw that up there. You can, well, I think it's I have to have a using statement. Don't know, that was scary. So if you're done web development, you're looking at this going, oh yeah, ASP.NET Core has let me do that forever, right? So I almost never use that. And almost never, I sometimes do, right? But that blocks the user from the entire page. It gives them a 404. What I find is that in real life, most of the time, when a user tries to go to a page, they can almost always get to the page. They just may or may not be able to see everything, right? And that's much more common, especially in a business application, because this authorize is probably a business rule that says, well, you can see the user's name, but you can't see their salary because unless you're in HR, right? And so I almost never use this. And instead, I'll use this type of technique, and I'll say, okay, well, I'm going to surround the sensitive data like your social security and salary in a tag that only displays if you're in the HR role, but you still get to see other information about an employee, even if you're not HR, something like that. So you can hopefully imagine how that works. So the other piece that I want to talk about in this particular app is that this app, and in particular, let's get rid of this though before I forget and do bad things, is that this another page is set up to be, let's make it interactive auto so I get my full demo. So interactive auto. So this page is going to render in 3 different modes, right? And this is true for like the data and everything I've been showing you. This page will render in 3 different modes. Step 1, it's going to render with server-side rendering, SSR, show the user something as quick as possible. Step 2, it's going to render in interactive server. So the code is running on the server, and displaying stuff in the browser. And then step 3, it's going to render in the browser. Well, when it renders on the server, it has easy access to the user identity because we're running an ASP.NET Core, and so we're running on the server, and so the user identity is literally right there. It's on the server, no problem. When it's rendering or running in the browser, how does it get at the user identity? This is a problem that you have to solve, and I'm going to show you how to solve it. And actually, this is just a common repeating pattern. So when you go look at that data app that I was showing you earlier, it does the same exact thing. And so what happens here is that when I render on the server, this user display, like I said, gets the authentication state provider injected. It makes sure I actually have the authentication state provider. It gets the authentication state, and then it pulls out the user, right? Well, this authentication state provider object on the server is just always there. Why is it always there? It's always there because I did that cascading authentication state, right? So it's an ambient value that's always available. On WebAssembly, it's there, but it's always null because there's nothing automatic that extends the user identity into the browser. And so to make that work, what I've done is on the server, I created a controller called auth controller. And auth controller has a get user method, and the get user method goes out, gets the current user identity from ASP.NET Core, and then converts the claims principal into a serializable POCO or DTO, data transfer object. Basically, it converts it into JSON, is the short way to put it. So remember on that page, right, where I had all the list of roles and stuff? All those are just strings. And so it literally just converts that into JSON and sends it back. And so on the WebAssembly client side, I have my own custom authentication state provider. So when you ask it, when you ask the authentication state provider for the current user, what it does is it calls that controller, gets back the JSON, and uses it to create a principal on the client side. And hopefully I didn't. So here's the problem. When you're running in the browser, code in the browser is inherently insecure. Let me even be broader on that. Code running on any client device is inherently insecure. How many people play video games? How many of you are aware how many billions of dollars get spent by EA and other companies in order to defeat cheaters, right? It's because even something as sophisticated as Call of Duty or Battlefield 6 running on a client device is crackable. Do you think your code is any less crackable? Obviously not. Do you have the billions of dollars that EA has? No, none of us, well, almost none of us actually have that budget. Therefore, you just have to assume that any code that's running on a phone or a PC or a tablet, if it's running on there, it's crackable, right? And so Microsoft, assuming that it's crackable, basically said, we're not going to solve this problem for you because we don't want the liability, but it's easy enough to solve yourself. And so if you're writing a business app, and here's, on one hand, I'm hopefully scaring you a little bit, right? But this is not a Blazor issue. If you're using Angular, you're using React, you're using WPF, you're using Windows Forms, all of those are equally secure to Blazor. Blazor is just as secure as anything I just listed, right? They all have the same architectural flaw that they're running code on the client device. And if you're running code on the client device and you want to be able to know who the user is, like what the user's roles are, you have to somehow export the roles from the secure server into the insecure client, right? That's all this is doing, is saying, okay, I'm tapping into the Blazor security infrastructure. So when Blazor asks for the current user identity, I'm just calling to the server, having the server package up a copy of the user's roles and sending it back. Now, can I count on these roles to be secure? Technically, no, but I want to give my honest users, the 99.999% of the time, I want to give my good users a good experience, right? So I kind of need to have that data. But one thing that you probably want to keep in mind is that if your claims principal has a claim that is sensitive, right? Like a social security number or something, which would be a dumb thing to put in a claim. But suppose you did put in a claim something that is sensitive. Right here, I go through and I pick out all the roles and clone them. You could filter out any sensitive roles or sensitive claims so that you don't export PII. I don't know. You see does that make sense? Right? So you can use some intelligence here. Or you can say, nope, I'm not doing that at all. We're not going to export this to the client, at which point either you can't use WebAssembly at all, or any of your pages in WebAssembly can't use the authorized view because you don't know who the user is.
That transmission in clear text.
This transmission is over HTTPS, and so it is not in clear text. Kind of the same thing. Here I've got an app. I'm using the NuGet package, MSAL, from Microsoft that does a lot of the work for me. And so I don't have to do nearly as much of what I just showed you. All that manual work is largely wrapped up in the MSAL Microsoft authentication library, right? But the reason I went through what I just did, again, is because a bunch of you might have your own custom security, and that's now you know how to do it. And those that don't, you still know that this little line of code actually is doing a lot of heavy lifting, is basically the deal, right? If we look at authentication.razor, and this little line of code is doing a lot of heavy lifting. So instead of a login page that I had to write, I've just got a login page that says, okay, when the user wants to log in, I'm going to use the remote authentication view from Microsoft to do the authentication. And so if I run this app, here we go, completing login, and you can see that it just logged in because I'm already logged into this browser, right? Because I'm single sign-on, right? And so of course, if I log out, now I get the regular Microsoft login thing, right? Because I'm logging into, and so I should be able to say, okay, I would like to sign back in. But basically now I've just completely tapped into the normal browser behavior where it interacts with my OAuth provider. And the fact that my browser auto logs me in is a personal choice, right? But there we go. And then this is using Microsoft Graph, because once I'm logged in, and so this is the thing, basically all modern authentication is a two-step process. Step one, verify your credentials. Step two, go get the user profile. And so even in my code, when I showed you that, I had the validate credentials and then the second step to go get the roles. Same concept, right? Prove the user is who they say they are. Now that I know who you are, now I will make a separate call to go get your roles, your profile, whatever it is. Same thing here. It verifies who you are and then makes a second call to the Graph API in Azure in order to find out that, here's whatever, my full name and email or whatever, right? So at this point, you've at least had a glimpse of how to talk to databases, how to log people in, how to use components and reusable UI widgets inside of your Blazor. This is like, rapid fire stuff, right? But one of the most common things that you need to do in an app is style it. And there's so many ways to style it. This is, a lot of basic styling you can just do through CSS all by yourself. This demo takes it just a little bit further. But first off, what I do want to cover is that there is app.css, which is just your basic app global CSS file, okay? It's also the case that an individual page can have a CSS file. So notice here, hello, that my home.razor actually has a home.razor.css. And so the app CSS is global, but for a particular page, you can actually have CSS, and there's nothing in here right now, but you can actually have CSS that maybe I grab, the H1 focus, and I'm like, well, on the home page, I want H1 focus to be different. And so I can override the global just for a specific Razor page or .razor file, okay? And what happens at build time is that the Blazor build process goes through and finds all of your CSS files for all of your pages and merges them into a single CSS file so that they download efficiently. Does that make sense? Right, so I mean, there's some work that involves or that happens there. And for the most part, if you're using Bootstrap or Tailwind or whatever else, it's all totally sufficient. Everything you need to do, you can do in app CSS or in CSS within a page. However, I ran into a case where I'm like, I'm using Bootstrap and I want to change some of the Bootstrap behaviors, like globally. Well, it turns out that the way that you do that, and this isn't a Blazor thing, right? This is just a Bootstrap thing. The way you do that is you rebuild Bootstrap as part of your build process. And the tool chains for React and Angular, they've got ways to do that. It is a place where Microsoft has not yet done a great job, in my opinion, in supporting comparable CSS alteration or rebuild type stuff. Luckily, there are people in the world that have built things such as the Dart Sass Builder NuGet package. And the Dart Sass Builder NuGet package in your CS proj file allows you to set up just a little bit of configuration that says, hey, basically, I want you to go rebuild custom.cs include this and overwrite and output the result here is what's going on. And so if we look at my solution down here, I actually have all of Bootstrap because this is how it works, right? You go out there, you grab the source code for Bootstrap, put it in your project, and then tell the Dart Sass builder that it should rebuild that entire thing every time that I do a compilation, right? But what this allows me to do is have a custom.scss And in here, I can do things like override the primary and secondary colors for the entire Bootstrap theme. Now, this is pretty extreme. You almost never have to do this, right? But if you do, you do. And so I just wanted to walk through that. So, right, so if right now it's green, let's make it red. That'll be garish, I'm sure. So right now I'm building, and you can, in fact, if we look quick down here, quick like a bunny, you can see at Sass compile finish. That was the Dart Sass builder that did that. And if I go to the counter, now my button is all red and garish, right? But now globally, every primary and secondary color that's used by Bootstrap. And so it's like bringing a hammer, like a sledgehammer, to a place where you need a screwdriver, in my opinion, right? All I wanted to do was to change the doggone button color, right? Which you can do just by overriding the button colors, but I wanted to do it quote unquote the right way, right? And the quote unquote right way is that you change the theme color. Well, to do that, you have to rebuild Bootstrap. So, craziness. My point is not that I did that, but my point is actually that if you need to do that, the tool that you should go look for, because there are several out there, but the one that actually works the best that I'm aware of, again, is this Dart, where are you? Is this Dart Sass builder NuGet package. All right, and we're almost out of time. Yep, all right, so this is perfect. So the last thing that I want to show you is Blazor being used to create a native app. And actually, I'll broaden that a little bit. So you can use Blazor in two different ways to create apps that can run offline locally on a client device. So how many of you are familiar with the term PWA, or Progressive Web App? Yeah, less than half. So this is an underappreciated, in my opinion, underappreciated technology that's been around now for a long time. Google invented it originally because Chromebooks, when they were pushing Chromebooks really hard, needed a way to run things like Google Sheets offline. Well, Google Sheets is a freaking website. How do you run it offline? Well, they had to invent a technology, and so they did. They invented this progressive web app technology. And what happens is that a progressive web app has a manifest file. And the manifest file tells the browser, hey, if the user wants to install this, here's all the stuff you have to download and cache on the client side. And then once you've done that, now this thing can run on the client side. And now you've got a client-side website that if you did it right, can even run offline, which is just pretty amazing, right? And so every web developer out here could be doing that, right? And probably should be. And so it's amazing, actually, how many apps, how many websites out there in the world, in fact, are PWAs, and very few people know about it. And so this particular app that I'm going to show you does a PWA. Also, it uses what's called a Maui Blazor Hybrid scenario, which allows you to create a true native app for iOS, Android, Mac, and Windows. And for iOS and Android specifically, because these are true native apps, in order to get them on a phone, you have to go through the Apple Store or Google Play Store, or you have to be able to do side loading, right? And Apple makes side loading particularly hard. Android has made it relatively easy, but they're tightening it up now too, from everything I'm reading. So basically, if you go down this Maui route, what you're saying is, at least on phones, you're going to deploy through the store. On Windows or Mac, you don't have to go through a store, because you get a packaged installable unit, an AppX for Windows and a whatever it is for Mac, that you can just directly install on the device, right? So, but in any case, these are true native apps. And so because they're a true native app, they're not bound by the browser sandbox. They can reformat your hard drive. All the things that you can do with a Windows Forms or WPF app, you can now do with a Blazor app that's wrapped in Maui, right? So the thing that I'm going to just briefly show you some of here is a real app. We're in the process of getting it certified for the Apple and iOS stores. And I'm going to run it first in an Android emulator, and I'll talk about it while the Android emulator starts up. So my wife is the executive director for a nonprofit called Missing Children Minnesota. They help find missing children and help support families that have children that are missing. So what she does in life is way more important than anything I do. That's the way I think about it. And one of the things that most organizations like that have is some sort of a pamphlet that they will give to you as a parent and say, hey, here, write down your kid's description, height, age, weight, hair color, all this stuff. And then if your child ever went missing, you've got all of this recorded. Well, that's not very useful because kids grow kind of fast, right? And also this sheet of paper, you're probably not carrying it with you. And so it's not where you need it. It's in a drawer at home, right? So the idea here is, how about if on your phone, we had the same thing, except it was on your phone. And then every now and then the phone reminds you, hey, it's been 6 months, your kid probably grew 3 inches. You might want to update, the idea is to make this actually useful for the real world, is the idea. And so here's the app. I'm just going to, oops. But this is all written in Blazor. Right now it's running on an Android device, very slowly. So I've got a 1-year-old child here. Why this is so slow? Why is it so slow? I think I've got 5 or 8 Visual Studios open is why. But basic child information, distinguishing features, family members, all sorts of things that you might need to know about a child, or that the police might need to know, or other authorities, right? Were your child to go missing, it's like, oh, my child has diabetes, or whatever it might be. All of this information is there, and then there's a way to send all the information via an email to whoever you might need to send it to in the case of an emergency, right? And so all of this was written, again, using Blazor. And so if we look at the solution, there are several different projects here. And so there's the kidsidkit.core. This is the actual app itself. This is a Razor class library, so it's a DLL, but this is where all the pages are for all of that stuff I was just kind of walking through. This is all in that DLL. And the reason it's in a DLL is because then we can host it in a mobile project. So this is a Maui hybrid project. And in here, and it references this core, right? So it's actually using all that Blazor code, but it can have, if we need to, specific code for Android, for iOS, for Mac, for Windows. And Tizen is like a Samsung television operating system or something. We've kind of ignored that. But any code that I write, like in this Android folder, this ends up being Android native code that only gets compiled for Android. And anything that's in the iOS folder similarly only gets compiled for iOS, and it does contain iOS specific code for using iOS APIs or whatever it might be, right? Our app doesn't currently use much or any of that because it's very data focused, right? Then the other thing that we do is we've got Kids ID Kit Web. Well, this is a WebAssembly standalone WebAssembly project, and you can see. Oh, you should be able to see static web app config.json. So it's got the manifest that makes it work as a PWA. And so what that means is if I switch this over to run the web, switch this over to run the web version, and then I run this thing, and then we look, this is the way Edge does it. Every browser does it a little different. But so you got this little icon up here in Edge that says app available. I could install this as an app. Right? Chrome, Safari, all the browsers do this. It just has a slightly different visual cue. Even on your phone, it's usually like add to phone desktop or something to that effect. But it literally installs it on your phone because this app stores all its data local. So this, right? Now in our case, and you can see it's the same, it's literally the same app. It's a Blazor app that's just running, in this case, in the browser instead of in a phone. In our particular case, the reason we're focused on native apps isn't because we need any native features, it's because we want the credibility of being in a store, right? Because as a parent, are you gonna trust your data to some random website? Your child's data, probably not, right? But you might trust your child's data on an app that you literally got through the Apple Store, right? And so this is the goal. So we've been working on this now for quite a while. We're literally at the point this week where we are working to get it deployed into the Apple and Google stores. And I mean, it's not done yet by any stretch, but we're at least at version 1, right? So it's pretty cool. But and I don't have the time, or in fact, we're out of time to go through the code, but I did want to show you what's possible from using Blazor all the way from, hey, I can create simple websites through interactive websites, through PWAs, through true native apps that can run on Windows or Macs or phones, right? So again, very quick, high level from zero to at least some basic pragmatic concepts. If you're going to be here on Friday, we're doing all of this only much deeper because we're spending all day on it. Also, I think in September, October timeframe, something like that, Alan Conway and I are doing an online Blazor course through the VS Live folks. And if you want information about that for yourself or your organization, check with Danielle at the desk because she'll have all the details. Thank you all so very much. Appreciate it.